A sweet seller has 420 Kaju burfis and 130 Badam burfis. She wants to stack them in such a way that each stack has the each same number and they take up the least area on the tray. What is the maximum number of burfis that can be placed in each stack for this purpose? So here we have 420 Kaju burfis and 130 is almond burfis, and this 420 burfis have to be stacked. We don't know how many are there in one stack, but the full 420 have to be stacked, and the 330 also have to be stacked in equal number of stacks. So let the number of burfis in each stack be x. Like in this x. So 420 have been stacked in this, here also in the same number of stacks. Okay, so we say let the number of burfis in each stack be x. Now here if you see, this 420 has to be divided into many stacks, each having x. So you know that x is a factor of 420, and the 130 burfis also have to be divided into many stacks like this, equal number of stacks, which is x. So x is also a factor of 130. So x is a common factor of 420 and 130. Of 420 and 130. So to find x, we find HCF of 420 and 130. So to find the HCF, we take the prime factorization of 420 equal to 2 square into 3 into 5 into 7, and for 130 the factors are 2 into 5 into 13. Now we need to find the common factor and the lowest power. The common factor is here 2 is the common factor, and 5. Lowest power is 1. So HCF equal to 2 into 5, which is equal to 10. So the HCF here is 10. Means the maximum number of burfis in each stack is 10. So this is the answer. This means these 420 burfis are divided into 42 stacks. Each one will have like 10 of them here. This will be another 10, another 10, and the 130 also are divided into many stacks, and each stack will have 10 of them, so they'll be of the same height. 10 burfis kept one over the other. Show that any number of the form 4 raised to n will never end with the digit 0. So 4 raised to n, 4 is 2 raised to 2, whole thing raised to n. So 2 raised to 2n. So thus we see that the prime factorization of 4 raised to n will have only 2 as the prime factors. To end with 0, it should have 2 as well as 5 as a prime factor. It should have 2 and 5 as prime factor, because 2 5s are 10. As 5 is missing as a factor, it will not end with 0. You also have to mention that by the fundamental theorem of arithmetic, that the prime factorization is always unique. The prime factorization of a number is unique. Given that the HCF of two numbers is 23, so HCF of two numbers 23 and their LCM is 1449. One of the number is 161. So one number 161. Find the other number. Let the other number say be x, and we know that HCF into LCM equal to product of numbers. And the HCF in this case is 23, LCM 1449, product of numbers, one number 161 into x. So your x equal to 23 into 1449 over 161. So the x equal to 207. Remember this formula. Different sums can come based on this formula. Find the greatest 6-digit number that is divisible by 24, 15 and 36. So I need to find a 6-digit number like 1, 2, 3, 4, 5, 6. Yes, 6-digit number, and it should be divisible by 24. It should also be divisible by 15 and also divisible by 36. So that means let the number be x. So here I'll just raise this would be x now. The x should be divisible by 24, remember 6 digits, huh? And this x should be divisible by 15. This x should be divisible by 36, which means x is multiple of 24, x is multiple of 15, x is multiple of 36. So x should be the LCM. X is LCM of 24, 15 and 36. So now you find the LCM of 24, 15 and 36. So 24 I can write as 2 raised to 3 into 8, 15, 3 into 5, 2 raised to 3, that is 8 into 3, and 36, 2 raised to 2, 3 raised to 2. For LCM, we need to write all factors, and all factors will be 2, 3, and 5, and highest power. Highest power of 2 is 3, of 3 is 2, and of 5 is 1. So the LCM will be equal to 2 raised to 3, 3 raised to 2 into 5. So LCM will be 360. But remember, we wanted a 6-digit number. 360 is divisible by 24, by 15, and by 36. But we want a 6-digit number. 360 is not 6-digit. 360 is only 1, 2, 3-digit number. Now, how to get a 6-digit number? So for that, you have to take the greatest 6-digit number. So the greatest 6-digit number is 999999, and divide it by 360. So now we'll do the division. So here's the division, and it's clearly, we see that 99999 is not divisible by 360. So the number divisible by 360 will be 99 minus 279, and that is 999720. So if we see 999720, 1, 2, 3, 4, 5, 6 digits. It's 6-digit number, and it will be divisible by all 3. It is divisible by all the 3 numbers: 24, 15, and 36. So the answer is 999720. 144 cartons of Coke. So we have Coke, and we have 144 cartons. 90 cartons of Pepsi. So here 90 cartons of Pepsi. 90 cartons are boxes. If Pepsi are to be stacked in a canteen, each stack is of the same height and is to contain cartons of the same drink. What would be the greatest number of cartons each stack would have? So this 144 cartons, again we need to stack them up in equal heights. We don't know how many. And then we have this Pepsi, which also has to be stacked up. Here also we do not know how many. So we say let the number of what would be the greatest number of cartons each stack would have. So here say the x, we don't know how many. Here too there will be x, and x. In each stack there are x. So we need to find. So I'll say let the number of cartons in a stack be x. So this 144 has to be divided in many stacks. We don't know how many stacks, and we don't know how many in each stack. Each stack should have x. So you know x is factor of 144. In the similar way, this 90 also has to be divided into many stacks. So here also x is factor of 90. So x is the HCF common factor of 144 and 90. So to find the HCF of 144 and 90, we need to do first prime factorization. 144 will be 144 can be written as 2 raised to 4 into 3 square, and the 90 3 square 2 into 5. Now to find the HCF, we have to find common factor, and here the common factors you will see is 2 and 3. 2 and 3, and the lowest power. The lowest power of 2 is 1 and of 3 is 2. So we have HCF equal to 2 raised to 1, 3 raised to 2. So 2 into 9, HCF equal to 18. So the number of cartoons in each stack will be 18. That's the answer. Number of cartoons in each stack equal to 18. So this 144 will have to be put in many stacks. Each stack will have 18 cartoons, and another stack will have 18 cartoons, and so on. This Pepsi also has to be done in many stacks. Each stack will have 18. Each stack will have 18 cartoons. What is the maximum number of factors of a prime number? Like take 7, prime number, 7 into 1, 2 factors. Say another prime number 11, 1 into 11, 2, 2 into 1, so 2 factors. You have to remember 1 is not prime number, not prime or nor a composite number, because it has only one factor. Given the HCF of 16 and 100, so one number is 16, the other number is equal to 100, and they said the HCF is 4, so HCF equal to 4. We need to find the LCM. LCM say is X, and we know the formula, HCF into LCM equal to product of numbers. So the two numbers are, HCF is 4, LCM is X, numbers are 16 into 100. So X equal to 16 into 100 over 4, and this is equal to 400. So the LCM equal to 400. Write if 348 over 28 is terminating or non-terminating without actual division. So 343 over 28. Let's do the prime factorization. 247, 7, 7. 28 is 7 into 2 into 2. So this cancels out. So this became now 49 over 2 raised to 2. So the denominator is in the form of 2 raised to m, 5 raised to n. That is 2 raised to 2, 5 raised to 0. Therefore, 343 over 28 is a terminating decimal. Explain why 7 into 13 into 13 is a composite. So let's start with this. 7 into 13 into 13 plus 13. Here we'll take 13 common out. What remains inside? 7 into 13 plus 1. So into, this is 91 plus 1, 13 into 92. So we see the number has more than 2 factors. The number 7 into 13 plus 13 has more than 2 factors. Therefore, it is composite. Here 13, this can be done 2 into 46. See, it's 3 numbers, it's 3 factors. Now the same thing we need to do for this number. So we have to show it is composite. So 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. I'll take 5 common out. What will remain? 7 into 6 into 4 into 3 into 2 into 1 plus 1. So 5 into, let's multiply this. We're going to multiply this and find the product, and that is 1008 plus 1. So 5, 1009. Now it is 5 into 1009 plus the number also will the number itself is a factor. So definitely the above number has more than 2 factors. So it is composite. 5 is a factor, 1009 is a factor. See, 5 will be one factor, 1009 is a factor, and the number itself is also the factor. So it is at least 3 and above factors.